Alright, so hopefully that looks familiar to most of us. Let's look at another example. Good old x squared plus 2x plus 1 equals 0. So in your head you're probably thinking pretty easy, right? X squared plus 2x plus 1. We can just factor that down to x plus 1 times x plus 1. And we know that any number times itself is the same as that number squared. So we have x plus 1 quantity squared. Taking the square root of both sides, I didn't show my work here, but we'll get square root of 0 is 0, and then square root of x plus 1 quantity squared is just x plus 1, giving us a solution of x equals negative 1. Now I want to focus on this equation here and see how we can use this equation to create a perfect square, because that was part of our task, creating a perfect square. So let's look for how many x squareds we have. We only need one of these, so one of these larger squares. I have a 2x term, but again I want to make a perfect square, right? So I want to have both sides of my square equal. I know for my x, one of the sides is unit 1, so it has a length of 1 on one side, so I'm going to use that to build my square. So I have x plus 1 here and x plus 1 down here, giving me 2 x's, and then lastly we have our unit square, the term 1. So using these three terms from our quadratic, we formed a perfect square. And we can see that here because x times 1, if we looked at this as an area model, x plus 1 times x plus 1 is the same as x plus 1 squared. So it's nice that we can actually connect this model back to our quadratic, because we're going to be using that idea to create a new way to solve quadratics.